Okay, this is a hardware test. Oh, there we go. This is a hardware test for the RoboTub10000. We have an ESP8266. It's a Node MCU. Version 1 is the micro. I have this board here, which is the drivers for solenoids, a couple of Darlington transistors there, power supply for the Node MCU for the micro, and the power input. And the power, we have some low current DC voltage coming in from this power transformer, which is from Babyless bath spa thing, which is meant for use in a bath. So very legit. It's a 12 volt output. There's a RCD permanently attached. I'm going to appears to be on. We test it and we can reset it. This is on a short cable, so it can't get into the bathroom. And then I just I've run a temporary length of cable. Okay, so I've got it hooked up to my laptop, and I'm testing an Arduino sketch for trying out the various bits of hardware. It's currently running. This is a serial monitor, and it's showing the Dallas temperature sensor that's down in the bottom of the bath there. We have a very small float switch, which if we were to we can show that the float is switching between 0 and 1 there. It's normally closed, and it's broken when the float is lifted. That will be the level sensor. This is a tap assembly on the hot tap currently. It's a Wilco's tap connector, and the solenoid valve actuated by 12 volts. Requires some pressure, and then there's a focus. Then there's a 3/4 inch BSP fitting in between. A lot of PTFE tape, but it's still not enough. I do get some leakage, but that's okay. That's fine. So I'm getting some drips happening at the moment. The solenoid is below the level of the tap itself, but not subject to getting touched by the water, but that will be potted in epoxy. It's also above the overflow, and yeah, no, I don't want to argue about it, whether it's safe. It completely is, and I'll make it more safe, so shut up. Okay, right. So currently this isn't powered. This is powered by the PC over the USB. I need to test the test that I've got the right voltages on my adapter board. And do bear in mind that I'm decorating at the moment, so the bathroom is a mess. And everywhere's a mess. Okay, so I'm going to have to put this on tripod for a moment. So just have to secure this tripod. So that I can, with my meter, test the voltages. And 1 voltage, good. and I want to check that I'm getting what I expect here. Yeah, so I've got 12 and a bit volts on that side, and on the micro side 5.06 volts. So I think it's safe to connect up the Node MCU power, but I'm just going to do the ground for now, so we've got a common ground. I'll disconnect from the PC while we're doing that, and I can show you the PC sketch starting up. So the startup sketch uses using what would you call it? Wi-Fi, ESP8222 Wi-Fi soft access points type thing. So it will provide an access point initially, so you can configure which router to connect to, which is all standard-ish stuff. So I'm going to take the ground for this beastie and ground out this board, give it a common ground, and fire up the sketch again, which will automatically happen when I plug it in to the PC on the USB. So let's clear the output. What do I got? Nothing, because it needs restarting, no doubt, the serial monitor, as is the nature of the Arduino IDE. Fair enough? There we go. So instead I'm just going to reset. There we go. It's done a Wi-Fi station, blah blah blah, this, that and the other. Temperature 13.44 centigrade, which is cold because we have the house cold. And yes, on the serial monitor I've got a couple of commands that I should be able to use to test the solenoid, which is over there dripping. So one of the commands is what is it, hot tap. Hot underscore tap underscore 1. It doesn't understand that. Is it tap hot 1? I guess it's tap hot 1. One moment. Caps lock will help. Tap hot 1. Okay, it says. Oh, the hot tap isn't connected up. Fair enough. Let's do. Let's undo that and do tap hot 0. Okay. I haven't connected up the taps. So the solenoid outputs are on orange and blue wires here. So I'll fasten that up to the board. I only have the hot tap connected, so let's plug that fella in. I won't connect the cold tap because I'm not sure what its status is. And let's see what happens now. So, I don't know, what do we want to do? So, I'm hopeful. Oh no, maybe not. We'll see what happens. So, tap hot 1. Oh yes. The hot tap is running. The temperature is rising. I'm not sure if the sensor's getting that. It's not really in the right place. But the temperature is rising. And let's see how it turns off. Very good. Okay, I'd say that's a success. So the sketch now requires better use of the Dallas temperature sensor, because it's currently not using the right. It's using quite a lengthy process where it sits in a loop waiting for a reply from the temperature sensor, rather than getting on with the million other things the sketch needs to do. And I'll be implementing a sort of PID temperature control, so that we attempt to approach a required temperature using a feedback loop, with the hot and cold taps being controlled to adjust that temperature to reach the target temperature, which will be, for my bath, 40 degrees, which is the temperature that I enjoy. And the float switch will be adjusted such that when I get in the bath, the float switches actuate when I get in the bath, the water level raises to the overflow, just up to the overflow, and that means that I've got a mark on the bath where the temperature, where the float switch needs to be in order to stop at that point. Ideally, I'd have a depth sensor, but those things are expensive, and well, the unreliable ones are cheap, but reliable ones are very expensive. So I thought of using ultrasonics or all sorts of things, but they're all fraught with their own technical limitations. A simple float switch will do for now, because the original idea of the bath was to just have it fill until and not overflow, so automatically switch off the taps when it reaches the required depth or maximum depth. And I thought, whilst doing that, well, I may as well control the temperature to reach the target temperature by the time we fill the bath to the required level. Okay, so that's a roaring success. Still a lot to do, of course. I've got to create the web interface so that we can control things, and all the music and lights and speech and all of that thing, which will make it more fun and lots of wacky lols. Okay, thank you very much. Where's the thing to do the thing? Okay, bye.